Yeah, 3, 2, 1. Here it is. All right. So the first thing I want to do is I want to spend some time familiarizing yourselves with a deck of cards. So I have printed out a deck of cards. Unfortunately, we do not have colored printers, so it's in black and white. However, if you would like to get colored pencils later and color them in so you know what colors are supposed to be, that's fine. Okay, so the top row is all of your cards with a diamond on it. What color are those cards?
Red.
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 The next row.
Red.
Black.
Wait, those are red.
I was just waiting for people to stop singing songs and focus for once in your life. Your next row are all hearts. So yes, those are also red. Then you've got your clubs. Or no, I'm sorry. Those are your spades, my bad. And then your clubs.
Black.
And both sets of those are black cards.
It wouldn't die.
That's racist.
No problem. There you go, man. I love this marker. Okay, so we're going to use that to answer these questions where it says deck of cards quiz.
You got that. How many red cards? 26. How many aces? 13. Oh, no, I got it.
Teachers, please pardon the interruption. I need to make a public service announcement before my students that are co-oping leave the building. Students, especially those who participated in DCCC, seniors, if you have any outstanding fees or books, you will be pulled out of the senior assembly line and not able to walk. So please make sure you take care of all of those fees and books that you owe, especially those that belong to us regarding DCCC classes. I'm getting quite a few notices about that. So please make sure you handle your fees. You have one more day to do so.
See, that's why I go to the library. That's why I go to the public library.
It's just return what you borrow. It's not that hard.
Public libraries are better anyway.
Okay, so looking at that deck of cards, if you had to answer the question, how many red cards are there?
26.
26. Okay, I promise you, you will need this as you do probability next year and your senior year. No matter what senior math you take, probability does not go away. Okay, those of you that are freshmen right now, you're going to see it again your junior year when you take technically your fourth math. Okay, and then you'll probably see it again when you either take statistics with me or AP calculus with Miss Lance.
What do I take? Statistics with you. Definitely taking statistics, but all right.
So, number 2, how many aces are there?
4.
4. Okay.
I read it as like
Number 3, how many red aces are there? 2. How many clubs are there?
13.
Why do I hear so much conversation? How many tens are there?
4.
How many clubs and tens overlap? 1. There's only one card that is the 10 of clubs. How many face cards are there?
12.
12. Remember, face cards are just Jack, Queen, and King. Okay? Face cards are just Jack, Queen, King. How many queens are there?
4.
How many queens and face cards overlap? All of them. Perfect. 4. Okay. How many cards are less than 6 where aces are low? So that means ace represents a 1 here.
20.
20.
Wait.
You've got, hold on, you've got ace, 2, 3, 4, and 5 are less than
You're
6.
saying that all aces are low?
Yes.
Oh, but I thought the spade aces were high.
Aces,
It's
all
in a
of,
game. It's in a
no, all of your aces can either be represent as a 1, or they can technically represent as like a 13. Okay.
Okay.
So they can either be low or high. Okay. So this means we're counting all of your aces, all of your 2s, all of your 3s, all of your 4s, all of your 5s. Then I have 4 different suits. So that means that we have 20. How many even cards are there?
26.
What are my even cards?
20.
What are my even cards? 2.
Pardon the interruption, just one additional announcement. Teachers, please make sure if students do have fines or fees that they owe to you, that those are turned in to Ms. Floyd in the media center, and students have been notified. Thank you.
Okay, so there's 20 of them. Again, 2, 4, 6, 8, 10. And then you have those in 4 suits. So that makes it 20. Whoop, top of the other side. How many even cards are less than 6?
8.
Good. How many hearts are there?
13.
How many diamonds are there?
13.
How many hearts and diamonds overlap?
9.
0. How many spades are black? 13. How many spades are face cards?
3.
Ooh, you guys are good.
Aha.
Good.
Sorry.
I don't care what kind of game you play. I need you for the next 3 years of your life to play some solitaire, to play some spades, to play war with a deck of cards, Old Maid for all I care, 52 card pickup.
21.
Oh,
I like
blackjack.
that game. That's all.
Blackjack.
That's my favorite one.
Okay. How many cards are greater than 9 where ace is now a high card?
16.
There are 20. Okay. So when
Oh, I forgot to count the A's.
when aces are high, you've got 10, jack, queen, king, ace.
I didn't go back to the end.
Okay. So I want to be greater than 9 and a face card.
12.
12.
What? How many are
Okay,
face cards
so,
higher than-
Hold on. Woo.
Oh, you zoomed in. All right.
Okay. So I want to be greater than 9. So that leaves me with this and a face card. Well, 10s aren't face cards, nor are your aces that would be over here. So you only have king, queen, jack. Remember, ace is not a face card. A card that has an actual face on it is your face card. So you got your face, and your face. Okay? How many total cards are in a deck?
52.
That's why they call it 52.
52 card pickup. Look at that.
Try.
Okay. Quickly and quietly, I need you to glue in your deck of cards on page 155 and your deck of cards quiz on 156. No, I glue it up and down because it fits better.
Can you have me and Mommy local card there?
Somebody's knocking. We're popular today.
Mary.
Period.
Like, seriously.
Okay.
No, I'm not. She said,
Miss Smith, before
by a couple guys that didn't treat me right. I ain't gonna lie, cause I'm tired of the people. Show me what you mean. Make me believe. Oh, hold up, girl, don't you know you. Sorry, I stapled them all together because as I thought about it, if I laid all those out for y'all to pick up, it'd have been way too much.
Yes, man. That was on my chin. It really hurts. I don't like the entire week earlier was squeezing my chin, and I was
Trying
like,
to pop it?
no, he was just squeezing my chin. You ain't stop it.
Yes.
Oh.
Why? Because I'm just singing it? I can't help it. She loves that song, and she literally goes, you say, if it's meant to, she'll go, beep, 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 Riley, Riley. She cool. My daughter's cool because she's mine. That's how it works. All right. So,
No, she gave me a hospital. No, I ran. She called from her job, and like we called back, and it was like if you have been called from this number, you have to call their direct number. So I was like, let's call back just so I don't
okay. All right. So the next thing we need to talk about is a sample space. A sample space is a list of all of your options. So what a sample space does is it can help you identify all of the possible outcomes of an experiment. It can help you identify a list of all of the possible outcomes of an experiment. So in other words, what can happen? Okay. What can happen? So your formal definition, this is the collection of all possible outcomes. How'd you know I was going to say that? In an experiment. Okay, we're going to talk about two different ways to draw out a sample space. Okay. I'm going to tell you right now, my seniors are still struggling with writing out a sample space. Okay. It's not difficult. I just feel like they haven't retained anything from like Math 2. Okay. A sample space can be used to find the probability of an event occurring. Okay. So it says the table below, use the table below to find the sample space for tossing 2 coins. Okay. So coin 1 is a nickel. What can I get if I flip a nickel? Heads or tails. So coin 1 has 2 options, heads or tails. Coin 2, penny, heads or tails. So
What's so brother?
Stop. Grow up. Grow up. Okay, so here is one option. I can get a head on the first coin and a head on the second coin. Here's another option. I can get tail on a first coin, tail on a second coin. I can get what, Emma? I can get heads first and tails second, or I can get tails first and heads second. So there are your 4 options. Okay, think about it. Coin 1 had how many options? Coin 2 had how many options? What can I do with those 2 numbers to get 4?
Add them together.
You can add them together too, but I was looking for multiply. Okay, so if you take your amount of options and you multiply it against the amount of options, that will give you your total amount of options. Okay, so a sample space is you listing the options, or you can give them a total amount of options. So this means when I do probability, my bottom numbers need to be out of 4. Okay, so now that you have your sample space, it says, what is the probability of getting 2 tails? 1 out of 4. You only see that here. So your probability is a 1 out of 4. What about the probability of getting a heads and a tail?
2 out of 4.
2 out of 4. It doesn't say that heads have to come first, tails come second. You can also reverse them. So you've got 2 options here and here. So that's 2 out of 4. It's not the answer though. Thank you. Always reduce. Okay? We'll glue all these in at the end here. So just kind of set it aside for now.
You got this.
Okay, before I actually write out the sample space, let's see how big my sample space is going to be. So I'm spinning a spinner. The first time I spin it, it can land on how many options? 5. The second time I go to spin it, I can still land on 5 different options. So technically I should have 25 when it's said and done. Okay, so to write out the sample space, I could use a table like this. Okay, so these are all of my options for my first spin. These are all of my options for my second spin. So we're now going to combine them. So in this box, my first spin would be a red. My second spin would be a red. If I go down a space, my first spin is still a red. My second spin, though, is now a yellow. Red, green, red, blue, red, purple.
Yellow, red,
Yellow, red,
yellow, yellow,
yellow, yellow,
yellow, green,
Yellow, blue.
and yellow, purple.
Okay.
Green, red, green, yellow, green, 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 blue, and green, purple, blue, red, blue, yellow, blue, green, blue, blue, and blue, purple, purple, red, purple, yellow, purple, green, purple, blue, and purple, purple.
Okay, so if they ask you to list out the sample space, you can use a chart like this to help you organize it. Okay, because if they ask you to list out the sample space, this is what I'm looking for. I'm not looking for the fact that you have 25 options. I want to know what are your 25 options. Okay, so you can use the 5 times 5 to make sure that you have them all, but if they want you to list them, you have to list them. So now, what's the probability of spinning 2 of the same color?
5.
Woo! That was like all together too. 1/5. Okay, what's the probability of spinning a red and a blue? 2 out of 25. Again, they don't tell you they want red first, blue second, or blue first, red second, so you have to count both of them. What about a green and a purple? 2 out of 25. Bam! Another one bites the dust. Do, do, do. Another one bites the dust. And another one. And another one. Another one bites the dust. We can glue these 2 in. Let's glue these 2 in. Let's glue these 2 in. That's fine. 157 and 158, my friends.
In my bag.
We know.
So,
Right.
Miss Smith, don't tell anybody. But Miss Smith,
She's like, I'm your elder.
Miss Smith, yeah, don't tell anybody. But Miss B said that I could.
Bro, both of y'all act like y'all won.
Just, you know, cheating a little bit.
It's not bad.
Let's not put that out there. No, Miss B said that I could, I was like, hand sanitizer, make sure it has to say, and I got it. Thank you.
What?
That's what I said. I just need to stop.
Yeah.
All right. Another way that you learned how to create a sample space was using a tree diagram. Remember, it branches off and branches off and branches off and branches off. Okay. So, a tree diagram can be used to show a sample space. Well, we're talking trees, so each branch of the diagram will represent one possible outcome. Okay, that branch has to go from the trunk of your tree out the whole way to get the total options. So you can then use the tree diagram to figure out the probability of an outcome. So this is just a different way of doing exactly what we just did. Tree diagrams are useful to help chart possible outcomes. All right, so each time we branch out, we're looking at what's happening. So it says we're tossing 2 coins. So we're back to that first example that we did. We're tossing 2 coins. So this first branch will lead us to our options for toss 1. So the first time I toss my coin, what are my options? Heads and tails. So one option goes to the edge of this branch. One option goes to the edge of this branch. Okay. We're tossing it twice. So off of these first branches, we're sprouting out again for toss number 2. So I can get heads on toss number 1, and that can branch out into heads or tails. I can get tails on the first one, and it can branch out to heads and tails. So my final options then are my branches together. So My first branch is heads, heads. My second branch is heads, tails. My third branch is tails, heads. And my last branch is tails, tails.
Just take me back to science class.
Oh, sure.
Like it looked like one of them faces.
Oh, anaphase.
Yeah.
Anaphase. It's
Yeah,
anaphase.
Oh, this.
Metaphase.
Prophase,
Telophase.
metaphase.
Look at that.
It's a metaphase.
Pay attention.
Isn't that like the cycle of a cell or something?
I said
You
NFL.
learned it in my
Okay, so
What they do?
these along the sides tell me that my total is a 4. So my bottom part of my fraction is a 4. Then I need to figure out what I'm putting on top. What's the probability of getting 2 tails? 1 out of 4. Bam, done.
Is this page 159?
Hold on, let's do the other tree diagram and then we'll glue in both of these. All right. Boom
I
shakalaka.
used to always say that.
All right. So we need to draw a tree diagram to represent this. You go to order ice cream sundaes, and there are lots of options. Each sundae includes one flavor of ice cream and one topping. There is a strawberry, vanilla, and chocolate ice cream. You also get the choice of toppings. You have sprinkles, hot fudge, whipped cream, and cookie crumbs. Create a diagram to find the sample space of all the different ice cream sundae options. So our first branch leads us to what? What do we need to pick first? We need some ice cream. So I need some ice cream. Okay, so we've got vanilla, chocolate,
And strawberry. Right, she should.
Yes, chocolate is nasty.
Chocolate's nasty.
It tastes fake.
Without.
Listen.
Oh,
y'all taste fake. Let it go.
it's good with
Whoa.
Okay, once we've chosen ice cream, we then need to choose toppings. So, if I order vanilla, I can put some sprinkles on it. If I order vanilla, I can put some hot fudge on it. If I order vanilla, I can put some whipped cream on it. And some cookie crumbs. Okay, those were my topping options. Well, guess what? We've got the same thing for chocolate. So I can order sprinkles, hot fudge, whipped cream, cookie crumbs, and strawberry. I can order some sprinkles, some hot fudge, some whipped cream, or some cookie crumbs. So now that you've drawn your tree diagram, what is my total options?
A lot.
vanilla sprinkles, vanilla hot fudge.
How many total options?
12.
12. Okay, so I just heard Kathy say 4 times 3. I had 3 ice cream options. I had 4 topping options. That gave me 12.
You do that every time?
Or you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Can you do that every time?
Yes. Okay. So they want to know what's the probability that someone's going to choose chocolate ice cream and sprinkles. 1 out of 12. What about vanilla ice cream and hot fudge? What about strawberry and cookie crumb? Well, bam.
Have you ever tried? Never mind.
Okay, 159 and 160. See, I told you these were fast.
Wait, so
Tree diagram go on one.
Tree diagrams go on 159 and the other one goes on 160.
I'm just gonna wait because I have to go into so
That's fine. I can help you glue in at the end. Hey, does gluing really cost you to sit there and have conversation and not be gluing? And why are we not gluing? Because I forgot my glue. You just gave me that look like.
I mean, you sounded like a whole kid.
You sounded like my uncle. She sounded like
I don't think that's funny.
Okay. While we're waiting for some people to glue, counting principle, it just needs folded in half. I'm gonna read what's on here. I want you to think about it. Okay, it says, tree diagrams and sample space diagrams are great ways to find the number of outcomes possible. But are they always useful? Think of a situation where a tree diagram or sample space diagram may be too large or difficult to create. Describe that situation below. Think about it, write it down, we'll talk about it. Okay, so nobody's has to match in here. There are multiple different ways to talk about this. So do not think yours is wrong. Okay. You should, it was a full page.
Oh, there it goes, never mind. Oops.
Yeah, you got 52 freaking branches, that's insane.
Like, that's the first thing that popped up in my mind. That's way too. Rosie, really? You should think of
It was not going.
You did.
Hey, so, Emma, share what you wrote.
A deck of playing cards.
A deck of playing cards. How many playing cards do we have?
52.
Do you really want to draw out 52 branches?
No, not really.
No, that's insane.
What do you think?
Okay? That's way too big. Bless you.
Ow.
Did somebody have something different that they would like to share?
I have a question though.
Yes.
Could the numbers for the possibilities be exponential?
No, because you'd never be able to find the probability
Okay.
because it would never stop. What if I said you had to pick some pants, a shirt, a hat, some shoes, some socks, a belt, some jewelry, and a hat.
Some bras.
Right, some panties, a bra.
Some boxers.
Some
Do you know how big that's gonna be? You better get a poster board because you're not gonna be able to draw it. So as we add in more things to pick and more options to pick from, your tree becomes woo. You're not gonna be able to draw it on a normal piece of paper.
Like a family tree.
Unless you're a doctor.
Okay, so that's why they came up with what we call the counting principle. And guess what? You've already done this.
Times it.
So remember when we said your coin has two options, your second coin has two options, multiply them together?
Yeah.
That's the counting principle. Okay, so you have to decide what you're picking and how many options you have for each and multiply it all together. Kaboom. All right, so tree diagrams and sample space diagrams are great ways to find the number of outcomes possible. But the counting principle is a simpler way to find the number of possible outcomes. Because again, once it starts to explode that big, they don't want you to list the sample space anymore. They want to know how many options. So you don't have to list them. You're just going to have to tell us how many. Okay, so your formal definition is there are M ways. Okay, so M would represent some kind of a number. There are M ways to do one thing. And N ways to do another. Total outcome is M times N. Okay, so they'll tell you how many ways there are to do one thing. They'll tell you how many ways there are to do a second thing. And then you've got to just multiply them together.
See, if Michelle works on the day, she would have had this a day, you don't have to come in there and help.
Counting principle, yes.
She said, all right, guys. I was like, hey,
Okay, so number 3 says you have 4 different pairs of socks, 6 different pairs of sneakers. How many different combinations of socks and shoes do you have? 24. So you need to pick some socks, and you have 4 options. And you need to pick some sneakers, and you've got 6 options. So altogether, you have 24. Okay. Carlo's Italian Restaurant. You have 6 choices for appetizers, and why do I have to keep getting louder? Because you're being so rude. 6 choices for appetizers and 8 choices for entrees. How many different appetizer and entree choices are there? 48. Okay, so you're going to learn a little later, and means to multiply. So that's another way to decide that I need to multiply my 6 appetizers and my 8 entrees. So 48. Okay. Caroline has 11 different skirts and 13 different tops. If she wears a skirt and a top to school each day, how many different outfits can she wear? 143. Every day she needs to pick a skirt, and she can pick any 11 different skirts. And then she also needs to pick a top, and she has 13 tops to choose from. She has 143 different outfits. Okay. Be careful though. This is not saying that the outfits are going to match.
Okay.
You could end up with like a blue polka dotted skirt with like
A
Pink and
a
orange.
pink and orange like striped, I don't know, thing with a unicorn on it for all I care. Okay. So we're not saying that these are pretty outfits, but she could. Okay. The Dough Hut Donut Shop has 2 different types of donuts, 5 different types of icings, and 4 different toppings. If each donut has 1 type of icing, 1 topping, how many different donuts varieties are there? 40. So now, instead of just picking 2 things, I need a donut. I've got 2 I can pick from. Then I need to put some icing on it. Well, I've got 5. Then I need to pick a topping. And we've got 4. So when I multiply all that together, you've got 40.
That was easy.
I told you it was going to be an easy day. While it looked like a lot,
Is there a catch?
it's
I watched this
basic.
Last packet that I gotta do.
No.
There's a lot of homework.
You got homework?
You got homework? Probably. Wait, don't say that. Don't say that for.
I excel.
Just hush.
See, look, she's gonna give us our Excel.
Oh, that's
no, I'm about to just give Bobo some IXL because, he wants to be smart over there. I'm not going to make the whole class be punished.
161. Who said 161?
Yes, ma'am. This clues in on 161, and we've got one more to talk about. I told you we got this.
Is it past 3 yet? I'm not sure.
It's like 3:00 now.
Actually, it's 2:58. Actually, it's 2:59.
Actually, it's now.
Actually.
Yeah, it's 2:59.
Perhaps we would like to start saying that.
Perhaps.
Perhaps.
We're back on this.
Perhaps y'all get S. Stop playing. Take it out.
Like, take it out and like, push it out and then rub it on.
Okay. While you're gluing, listen to me talk. While you're gluing, listen to me talk. So, yesterday, we talked about theoretical probability. We said theoretical probability, I needed to know how many total options, and then on the top, I needed to know what I wanted. Okay, and how many ways I could do that. The difference between theoretical and experimental. Theoretical is what should happen. Okay, in theory, what should happen. So, in theory, what should happen? In theory, what should happen? What is experimental probability? What actually happens? Okay, I've now conducted an experiment. I've flipped a coin 50 times. I've spun a spinner 17 times. I've picked from a deck of cards 42 times. Okay, I've conducted an experiment. So what actually happens? So let's put after experiment. What actually happens? So I'm not going to open up theoretical probability because we already talked about it yesterday. So what changes when I do probability of experimental on this side is now in the bottom, I want the total times the event happens. Okay, so in other words, and if you want to put this too, how many times do you flip a coin? So you have an example to go back. So I'm not looking at 2 because that's how many sides are on a coin. I'm now looking at, did you flip it 50 times? Did you flip it 100 times? Did you only flip it 6 times? How many times did you actually do the experiment? Okay. The number that goes on top now is how many times your event occurred. So the number of times the event occurs. Oops, event occurs. So, in other words, how many times did it land on heads? So, if you conducted an experiment and you flip the coin 50 times, 50 goes on the bottom. Of those 50 times, it only landed on heads 17 times. So your probability, your experimental probability would be 17 out of 50. What's your theoretical probability though?
20.
Okay, hold on. So, theoretical says how many options do I have on a coin? 2. So that goes in the bottom. How many heads do I have on a coin? 1. So, in theory, if I flip a coin, it should land on heads just as many times as it should land on tails. It's 1/2, 50-50. Okay? But experimentally, you could end up with, I did 50 trials and only 17 times. Is that 1/2? No. Okay? So, theoretical and experimental usually does not match. Okay? Why? Who's conducting experiments? Humans. Do we make mistakes?
Yes.
Absolutely.
All the time.
Okay. You name me one person in this world that is absolutely perfect, that has never made a mistake in their life. Bobo, put your hand down because you full of crap. Kelly, put your hand down. You full of crap. Teron, never. Oh, Emma. No. There is not one person on the face of this planet that is perfect.
The stuff I do
Okay.
on purpose.
I may die of a heart attack.
Okay, first of all, I'm not that bad.
All right. So let's go to the bottom left flap. All right. So we have conducted an experiment. We have rolled a die 50 times. Okay. This is a frequency chart. How long has it been since you've seen one of these?
I've never
Wow.
seen one of these like that.
Really?
Yeah.
Okay.
We had
So a frequency chart tells you how many times each thing has happened. So it's landed on a 1 7 times. It's landed on a 2 5 times. It's landed on a 3 10 times. Okay. So a frequency is how often. Okay. The numbers are the numbers on your die. So in theory, answer me this question. What is the probability that you should land on a number that is less than 5 on a die? First off, how many total sides do I have? 6. So theoretically, I have a 6 on the bottom. Of those 6, how many are less than 5? 4. So that makes my theoretical probability 2/3. Okay, so we know what should happen. Now we need to talk about what does happen. So how many times did I roll my die? 50. It tells me that. So under experimental, my bottom number is 50. How many times in my experiment did I get a number that is less than 5? 31. Okay, so that is all of these numbers added together. That is a total of 31. So there's your difference. In theory, it should be 2 out of 3. Experimentally, not the same. This is more like, so 2 out of 3 is 0.66, and we've pretty much got like 0.6. Okay, so it's close, but it's not dead on. Okay, on the other side. I want the probability of a number that is greater than 6 this time. Let's do that.
Yeah, you have it in my mouth.
All right, so this time I am rolling 2 die. Okay, I'm rolling 2. Okay, so I'm now looking at the total when I roll the 2. So they gave you this chart right here. Let me blow this up for a minute. Okay, so what this does is if I roll snake eyes, my total's a 2. If I roll a 2, then a 1, my total's a 3, or a 1, then a 2, my total's a 3. Okay, so these are all of my options here. How many total options are here?
36.
How'd you get that?
6 times 6.
6 times 6. This is 6 options, 6 options. So this is out of 36. How many different ways can I get a number that is greater than 6?
20, 15.
21. All of your numbers that are greater than 6 are in this triangle. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Bless you.
Same thing.
So this actually reduces down to 7 out of 12. So in theory, every 12 rolls I do, 7 of them should come out to be a number that's greater than 6. Okay. So I've conducted an experiment. Okay. This is another frequency table, another way they can do it. So twice, they use little dashes. Twice I rolled a 2, 3 times I rolled a 3, 4 times I rolled a 4. What is my bottom number in my experiment?
12.
Oh.
Oh, wait, what?
How many times did I roll my die?
Oh, 60.
60. If they didn't tell you that, how would you have found it?
Counted all of the.
You would have had to count up all those hash marks.
Oh, I thought you were going to say hash
Hash brown?
brown.
Why, are you hungry?
I-
She's drinking food. Okay, so off the 60 times that I did this, how many times did I get a number that is greater than 6?
5,
3.
15, 43. Oh, wait, wait. 43. I'm pretty sure it's 20,
I think about 30,
35. It's 38.
Okay.
It is 38, which is actually 19 out of 30. Okay, so that's your difference. Questions or problems? Okay, that glues in on page 162, and we are done with notes.
Yay.